Okay, so I made this truss here, and there's going to be two ways that we can solve this, either the method of sections or the method of joins. And since I want to find the reactions in all of these, I'm going to do the method of joins. So first we want to make a free body diagram of this. It's going to kind of look something like this with a reaction here and here, which is a X and a Y, and then over here, which is EY. So our first step that we want to do is solve reactions. Okay, so when solving our reactions, we have one reaction coming down here and two reactions going up here. So we want to solve this by first solving our sum of forces X, which will equal 0. And if we have AY plus EY minus 20, because this value is 20, this will come out as AY equals 10 and EY equals 10, because they'll just split this value of 20 on either side. They'll be the load. So after you figure out all your reactions, you're going to want to split up and draw free body diagrams for each of your members that you're trying to solve. So I have 10 kilonewtons here. This is a B. This is a C. When you have this, then you solve for your reaction forces of X and Y. Since this is an equilibrium, all of these should equal 0. So we have our force of AC plus AB. And since all of these members are 1, each of these degrees are 60 all around this truss. So we have cosine of 60 degrees. So when you solve for this, you get AB, Okay, so we have two unknowns right here, so we can't solve for it. So we basically go to this equation, and then we'll get AB sine of 60 plus 10 kilonewtons. So if we have, now we have two equations and two unknowns. Now we can solve this equation, and we'll get AB equals negative 10 over sine of 60, which comes out to be negative 11.547. So since this is a negative right here, and we assumed all of our members in tension, it's actually in compression. So now we solve for AC, and we plug it into this equation. We plug this in right here, and we'll end up getting 5.7735 kilonewtons of tension. So since we solved this one right here, and we solved this and this, I'm just going to jump over to this side and solve this and this, and basically do the exact same thing. So we're going to draw this here, here, and then here of 10, and this is DE, and this is CE. So now we solve for our sum of forces. So our sum of forces is negative CE minus DE cosine of 60 degrees. Then we have our y, so we have 10 plus DE sine of 60 degrees. So same thing, we pretty much solve that this DE will equal negative 11.547. So this is also in compression, and this CE will equal 5.7735, and this is in tension. These are both in kilonewtons. So basically what happened on this side is what happened on this side. Same equations, same math, just opposite sides. So now we want to either plug in here or here or here, and I'm going to just jump down to this C right here. So we have a 20 right here. We're going to assume that these are going this way, and this is CD, and this is BC, and then we have this one going here, this one going here. And this one is CE, this one is AC. So again, we solve for our equilibriums. So this one, we have 5.7735 on both sides. This one's pointing this way, so we have a negative 5.7735 minus BC cosine of 60 plus CD cosine of 60 plus the CE, which is 5.7735. And then our equation down here would be negative 20 plus BC sine of 60, and this is also plus CD sine of 60. So when we solve this equation, we get something like this: BC equals CD over cosine of 60 and cosine of 60. These cosines cancel out, so we get BC equals CD. And when we do the math down here, we find out that both of them equal 5.547, and that's tension in kilonewtons. So BC equals CD. When you come down here and solve and plug in one of these, we get both of these equal 11.547. So for our last step, we have this member now, and now we want to solve for this member, so we can either jump here or here. I am going to jump to this side, so here, and then we have this, this, and this. The only problem is this was in tension. tension. So we have 11.547, 11.547, and this is BD. So sum of forces X equals negative 11.547 cosine of 60, and this is plus, no, this is also minus 11.547 cosine of 60. So when you, plus BD. When you solve this equation, you get that this is also 11.547, and this is in compression. So you get a minus, but that just means it's in compression, kilonewtons. So for a B, B, C, AC, B, D, C, D, D, E, and C, E. So 1, 2, 3, 4, 5, 6, 7, and there's 1, 2, 3, 4, 5, 6, 7 members. So each of these, so this is 11.547 kilonewtons, and this one is in compression. And we also have AC, which is 5.7735 kilonewtons, which is in tension. I did the exact same thing to the other side. So our DE is 11.547 kilonewtons, and this is in compression. And then our CE is 5.7735 kilonewtons, and this is in tension. We have our BD, which is 11.547 kilonewtons in compression. Our BC and our CD are the exact same, and both of those were 11.547 kilonewtons in tension. 11.547 kilonewtons in tension. So we have now solved for every single member inside this truss, and we did it using the method of joints. So overall summary, the method of joints is your number one, you solve for your outside reactions first, and then I guess this is step 2 and so on, is just solving for, breaking it up and solving for each one of these members at a joint. And that is how you use the method of joints to solve your truss.